Today we are starting a new chapter, fluids in motion. Okay, first we should learn what is fluid. Fluid is anything that can flow. Within fluid we have liquid and gases, both coming under the term fluids. Okay, whenever fluid moves, then we measure the rate of flow. First you have to know what is the rate of flow. Rate of flow. Rate of flow denoted by capital V. What is the meaning of rate of flow? Rate of flow doesn't mean speed. Rate of flow's meaning is not speed. Its meaning is the volume of the liquid, the volume of the fluid flowing per second. That is V is equal to capital V value will get this volume of fluid per second per unit time. Capital V will be equal to, what is the unit for this? Let us check. Unit of V. Unit of V will be, you can see volume unit is meter cube per second. It is not meter per second, it is meter cube per second. That is volume flowing per second or per unit time. That is called rate of flow. Rate of flow we can express in terms of the area of cross section and the velocity or the speed of fluid. Let us see how we can change it. That V, actual formula is volume upon time. Volume formula will be writing that area of cross section into the length. Suppose we are having a pipe here like this. Length of the pipe is L and area of this is area of cross section is A. Area of cross section. The volume formula will be having area of cross section into the length. A into length upon time. V as it is, area will keep as it is, length upon time, that is distance upon the time. Distance upon the time is called velocity or we call it speed. So we have the formula capital V is equal to A into V. Area of cross section into the speed of the fluid, or we can call it velocity of the fluid. So this is the formula. Capital V is equal to A and small v. Where A is what? We said where A is area of cross section of the pipe through which it is flowing through the pipe, and V is the speed of fluid. Small v. And if you check the unit by using this formula, unit will come in meter cube per second only will come. How area is meter square and velocity is meter per second. So meter square into meter become meter cube per second. Same unit will come. Then the rate of flow, if volume is given and time is given, we will measure this way. But if area of cross section is given and velocity given or speed given, we will measure this way. The rate of flow, V equal to A. Okay, now we have a definition of steady flow. Steady flow. What is the meaning of steady flow? Steady flow means when the rate of flow of it states that the rate of flow of a fluid, when the rate of flow of a fluid remains constant throughout. When the rate of flow of a fluid remains constant throughout, then such a flow is called steady flow. Such a flow is called steady flow. That means for a steady flow, we can add AV is equal to, we can add constant. That is actually capital V is constant first. But capital V is same as small a is constant. AV value will be constant. And according to this equation, we find that A and V, they are inversely proportional. It is like this. Therefore, from here we conclude V is inversely proportional to area of cross section. That means the point where the area of cross section is small, velocity of the liquid or fluid will be large or bigger. Area less, velocity more, area more, velocity less. And it is a matter of common observation. We see this in many situations. Like for example, showers or fountains, they have small holes, and you must have seen through this small hole, the speed of water which comes out is very high. Then if water comes out faster, the speed is very high because the area of cross section is less. Other side pipe is quite thick, but the shower which is connected to the shower, they have got a small area. I mean holes are there, small holes. That decreases the area of cross section and increases the velocity of the fluid, which is water here in this case. I think you must have seen that when we fill air using a pump, air pump in tires or bike or car, whatever it is, there is a small hole through which we fill the air inside the tire through the small hole. So you pump is quite thick out there. You press the piston down here like this and up like this we do, and the air, we make the air to come out through the small hole, because through the small hole, because area of cross section will be less, so velocity of the air which will come out will be very high. I think with high speed the air will be coming out. That is the idea behind. And fountains of the same nature, same, where area is less, velocity will be more, and where area is more, velocity will be less. You must have seen at home the water connection, the plumbing pipe for home, for inside the rooms and all, or inside kitchen or the washroom, we use thinner pipe. There is half-inch pipe we use, but outside we try to use the thicker pipe. Even the water supply is given through the thick pipe, but they are containing more amount of water, but with a less speed. But when we distribute water from it, we use a smaller pipe, thinner pipe. Thinner pipe will make the water to flow with a high speed. So with high speed, it can reach the place where you want to distribute it. So that is the idea. So this formula is very important one. And for two different cross sections of a pipe, we can write like this, the formula like this. A1 B1 is equal to, we can write A2 B2. This is the formula for 2 points. Because AB is constant, but this formula is valid for which kind of flow? For the steady flow. When the flow is steady, that means in between the water starts flowing without any air bubbles inside it. So then the flow will become steady. And for the steady flow, this formula is applicable or valid. Okay. Now the next topic within this chapter is Bernoulli's theorem. Bernoulli gave very important theorem. It's called Bernoulli's theorem. Bernoulli's theorem. What is Bernoulli's theorem? The Bernoulli theorem states that the total energy of a fluid, for a steady flow is for the steady flow per unit volume is constant per unit volume is constant. Therefore we write like this. Therefore total energy, then we can write like this: energy per unit volume is equal to constant. We write that first, per unit volume. Okay, now according to Bernoulli, fluid in motion will have three types of energy. It will have kinetic energy because of velocity, and the fluid must be flowing at some height from the ground level. So it may have a potential energy also, and formula which is mgh, and it will have, because liquid and fluid they exert pressure, So it will have pressure energy also. Pressure energy also will be there. So three kinds of energy we have. Kinetic energy, I like this. Kinetic energy plus potential energy plus pressure energy. Pressure energy. Pressure energy. These three energies together will be constant throughout the motion of, steady flow of a liquid, for the steady flow only. Normal formula kinetic energy we had actually like this much per unit volume. You divide by volume also. Divide by volume. It is not only these three heads, but divided by volume. Per unit volume remains constant. Kinetic energy formula we have half mv square. Potential energy formula we have mgh. Usual formula. Pressure energy formula is P, pressure into volume. Pressure into volume is called pressure energy. If you multiply pressure and volume, you will get the value of energy, surely. Because we can check also, pressure is caused by area and volume is area into the distance. Distance is suppose L. This will cancel. So force into L. Force means, and L is a kind of work done. Force into displacement or the distance moved by the fluid. So F into L will be same as work done, and what will do the work? Energy. That's why PV is also known. PV is known as pressure energy. Remember it, PV. So pressure energy value I write PV divided by volume. This volume I divide for each one. Volume formula. Okay, let us divide by volume here also. Here also divide by volume. Volume. Here also divide by volume. Is equal to constant. Okay, just interesting thing on half. Mass by volume. Mass by volume is called density. We have density rho v square. V is the velocity plus mass by volume we get rho gh plus this volume cancel. We have the answer coming only P is equal to constant. So we take the Bernoulli's theorem in this format. Half rho v square plus rho gh plus P is constant for all the points when the liquid or when the fluid is flowing with the steady rate, with the same constant rate of flow. That time the Bernoulli's theorem says this half rho v square plus rho gh plus P is equal to constant. For 2 points, the formula will change and now it becomes like this: half rho v1 square rho gh1 P1 is equal to this side like is half rho V2 square rho GH2 plus P2. For 2 points will be written like this. This is for the first point and this is for the second point. All the three energy at point A will be equal to all the three energies at the point B. This is the statement of Bernoulli's theorem. We will be doing the application of Bernoulli's theorem the next day. Thank you.